All right, guys. So just like in the other video about arcsine, we want to find the derivative of the natural log of x. And this again is an example of implicit differentiation, sort of appearing unexpectedly. So what we're going to do is we know that the natural log of x is inverse to the function e to the x. And so what we're going to do is we're going to let y be equal to the natural log of x. Right? And then we don't understand the natural log of x, but we do understand e raised to different powers, right? We understand how to differentiate that. And so what we're going to do here is get rid of the natural log by exponentiating both sides. Right? And so we're going to have e to the power of the natural log of x. They're going to undo each other because they're inverse to each other. And we're just going to have x is equal to e to the y. Now, differentiate both sides. All right, so differentiating the left-hand side, we'll do that on its own in a second here, is going to be equal to the derivative of the right-hand side with respect to x, but the derivative of x is just 1. All right, and now the left-hand side, this is really the chain rule because we've got something more complicated than just x in the exponent. All right, so we use the chain rule here. The derivative of the inside function is going to be the derivative of y. That's y prime. And if you look back at the top, that's really the thing that we're after, is y prime. And the derivative of the exponential function is itself. And remember that whatever's upstairs has to stay there. All right, so it's going to be y prime e to the y on the left-hand side. And that's equal to 1. All right, so now solve for y prime. Y prime is 1 over e to the y. And if you look right back here, e to the y is equal to x. And so y prime is 1 over e to the y, which is 1 over x. And there you have it. The derivative of the natural log of x is 1 over x.